In lesson 18, we're going to do the first example of time-dependent loading. So far in the previous 11 lessons, all the loading conditions that we applied to our models were static, which means that load did not change over time. But this time we're going to practice a model in which the load changes by time. And for the first example of such loading, I'm going to do an impulse loading. So basically what I'm going to do is I'm going to have, let's say, a beam made of steel, which is fixed at two ends, and I'm going to apply an impulse of, let's say, 100 kilonewtons at the center for a time period of only 1 millisecond, or thousandth of a second. This is going to and it's going to be a step load, so um, in a very short period of time, which is 1,000th of a second, a 100 kilonewton load is applied to this uh, beam, and I'm going to study the deflection of the center of this beam for 1 second. I'm going to see, if you recall, there should be a ux over time, which is probably a vibration. Uh, okay, so kind of a vibration movement in the middle of the beam is going to be seen when this load is applied for just 1 millisecond. Again, as I said, the material is going to be steel with the properties of 200 gigapascals for elasticity and zero point 0.3 for Poisson's ratio. I'm going to also include or add the density of steel to be 7,800 kilograms per cubic meters. Uh, for this analysis, the only thing that differs from the previous 17 lessons is the way that we're going to define the load. So when we make this model, key points and lines and meshing, everything is going to be the same as we did before. The only thing that's going to be different is when we start to define loads. So if you remember, anytime I went to analysis type, I picked uh, static, but this time it's going to be transient, which means time dependent. So I'm going to pick this one instead. And for this one, I will have three options, which I'm going to pick reduced model, which has the advantage of reducing the amount of work or analysis work that ANSYS is supposed to do. And then I have to define three load steps. So if you remember when I was doing this solve command, I was saying current ls. There should be two r's. Current ls. ls stands for load step. So for this one, for this loading condition, I'm going to define three load steps. The first load step is going to be at time of 0. This is the initial condition, which I'm going to have no loads but two uh, endpoints or fixed points. And then load step 2, which is going to last for just 1 millisecond. This fx of 100 kilonewtons is going to be applied. And load step 3 is going to last for from 1 millisecond to a second with no load, so fx is going to be 0, but the end conditions or fixed end conditions is going to be the same, and then I'm going to read the results for that. With this, let's go to ANSYS and do the analysis. Okay, in ANSYS, the first thing I'm going to do again is to make sure that I'm doing a structural analysis and come to preprocessor and pick element type. I'm going to pick a beam, and instead of using beam 3, I'm going to use or pick beam 189, which doesn't have a real constant, but we will define the cross-section area of the beam from sections. But before that, I'm going to come to material properties, material model, structural, linear, elastic, isotropic, and give the properties. Okay. And then come to density and pick density of 7,800 kilograms per cubic meters. And I'm going to come to sections, beams, common sections, and pick this square one and give the cross-section area of 1 centimeter by 1 centimeter. For the mesh part, I'm going to divide both faces by, or both sides by 5 segments. Then it's time to define the model. So I'm going to create 2 key points first in active CS of x of 0 and y of minus 0.5. Apply, and the second one is going to be at y of 0.5. Okay, so I have a beam with cross-section area of 1 centimeter by 1 centimeter and a length of 1 meters. Then I'm going to come to lines, line, straight line, and make a line in here. The next step is to do meshing. So I come to size controls, manual size, lines, and I can pick all lines and divide that by, I want to divide it by 10 segments. Okay, so my line is divided by 10 segments, and then I can mesh this line. So far everything has been the same, but when I come to loads, analysis type, new analysis, and this time I'm going to pick transient. And this window pops up that I can pick full, reduced, mode superposition. I'm going to pick reduced to because it has less workload on ANSYS to do the analysis. So I'm going to pick this one and click OK. Now I'm going to come to define, or before that, the other thing I have to do is to define master degrees of freedom, which is the main degree of freedom of the body. So I pick that one, user selected, and define. I pick all the nodes except for these 2 ends because they're going to be fixed, they're not going to be moved, or they're not going to move. So I'm going to come here, select box, and go from there to here and pick all the nodes except for the nodes in the top and bottom, and click OK. Now the degree of freedom that I want to use in this analysis is UX. So I want to have the initial or main movement in the X direction, and click OK. So this is applied. Now I come to define loads, apply structural displacement on nodes, pick this one and this one, and click OK, and pick all DOF equals 0. So these 2 ends are fixed throughout the entire solution, and this is the model, and the first load step is defined. So I come to load steps, time frequency, time step. In this window, the time at the end of load step is going to be 0, so this is the initial point. Load steps that I'm going to define is going to be 1,000th of a second, and stepped mode loading, and click OK. And then come to write ls file and pick a name, pick a number, or give a number for that. I'm going to pick or enter number 1. So this is load step number 1. I come back to define loads, apply. Instead of displacement, I'm going to come to force on nodes and pick this node in the middle, click OK, fx of 100,000 newtons, click OK. So the second load step is complete. I come back to load steps, again time frequency, time steps, and pick the end time for this one is 1 millisecond. Still the time size or step size is 1 millisecond, and it's in a stepped mode. Click OK, write ls file, give number 2 to this file. Come back to define loads, and instead of applying, I'm gonna delete the structural force that I applied to the middle node. So this load is deleted. This is the third load step. I'm going to come back to here again and say the end time is going to be 1 second, or let's make it more than 1 second because 100,000 newtons is a little bit high, so I'm give it 2 seconds. Still 1 millisecond is the time step size and step mode loading. I'm gonna click OK and then come to write ls file and give number 3. So the entire model is ready. I can come to solution, solve, and instead of picking current ls, I'm going to say from ls files that I just wrote. So I'm going to click here, and the initial one was number 1, the last one was number 3, and the increment was 1 by 1, so 1, 2, 3. I'm going to click OK. Solution is done. Now after solution, instead of going to general post process, I'm going to come to time history post process. So I'm not going to this one, I'm going to the fourth option in here, and a window pops up. The first one is time, which is going to be in X direction. I'm going to come and pick add data and select U in X direction because it's the direction of the load that I applied to the model in the center point of the model. Click OK. It wants me to pick a node for it. I'm going to pick the middle node and click OK, and it's defined. Now let's pick this button, which is graph data, and we see that in for 2 seconds period of time, this is the way that this center of the beam is fluctuating. I can also click list data and see the list of time and UX. This is a good file that I can just save it, for example, and as a text file, or LIS, which is basically a text file, and then I can load this file on Excel and replot this graph in a way that I can really see how it changes, because right now it's very accumulated in one area, so we can't really see. But one thing we can see from this graph is that it's damping. So if I had gone further in time, let's say to 5 seconds, probably it was stabilizing the center point of the beam. Now let's get back to solution. I mean, there's still more you can do in here, but we'll get back to that later. But let's get back to solution, analysis type, and click expansion pass. Click on in here, and then let's go to load step ops, and there is expansion pass defined in here. Click single expand, and let's pick range of solutions. Number of solutions to expand, I'm gonna give it a number of 10. Beginning time, I'm gonna say let's go from 5 milliseconds, and ending time, let's go to 0.1 seconds. So it's gonna expand the solution between this time and this time for 10 of the solutions that ANSYS did for this, or applied for this analysis. I'm going to click OK, and then I'm going to come here, solve, and this time I'm going to click current ls, click OK. Solution is done. Now after doing this, I can come to general post process and see the deformed shape, and this is the way it works. But one thing we need to realize or remember is that this is a time-dependent analysis, so this is not the ultimate deformation of this beam. So one thing I want to do is to come to plot controls, animate, mode shape, For whatever I picked, degrees of freedom, and then come to translation UX and click OK. So you will see this. This is the animation, which is showing me how this beam is deflecting based on this impulse load that I applied to it. If I decrease this delay time, you will see this animation is getting faster. So I can close this one, and I can also save it uh, here, I guess, save animation, but I'm not going to save it now. I can come to read results because we have a lot of or several load steps that we defined for this analysis, and there are several results that ANSYS has picked or has come up with for this analysis. So I can go to first set, which is the initial condition, and plot results, deformed shape, and see that this is that. Now let's get back to read results, last set, and get back there. As you see, this is changing. So again, if I come here and read results, and instead of picking first, next, and whatever, I just pick by time and frequency, and say at the time of let's say 0.8 seconds at time value, and click OK. Come back to deformed shape. I'm going to move this window here and click OK. Well, not a big change was shown. Let's read another result. Let's say by time and frequency at 0.01. Okay, and plot results, deformed shape again. This is a little bit different than 0.5 seconds. For this time period, I can also come to contour plot and pick DOF and X component. So the maximum or the biggest or largest deformation is taking place at this point at the center of 0.65 millimeters. And then I can come to list results and read reaction solution, all forces. I'm going to have only two nodes at this end and this end. So I click OK. So you see Fx, Fy, Fc, and other loads applied in here. But let's go back to read results and pick last set. Come back to list results again and reaction solution, click OK. So you see that everything is different now. And that's the nature of time-dependent loading in ANSYS or in any analysis. So for this time or for this type of loading, what you need to do is to pick the time that you want to or you're interested in finding the results for, and then for that time, you can read solution or reaction solution, nodal loads, and nodal solutions. So if I come here and pick nodal solution and X direction, I will see the displacements of all the nodes in this period of time. But if I get back to read results again here by time and frequency and pick that point of time, click OK, come to plot list results and nodal solution again, you see that things are not exactly the same as before. So this is the end of lesson 18, the first of our lessons in which we discussed time-dependent loading or transient loading. And I hope you enjoyed and learned from this lesson.